Gate 2021 Thermodynamics. The elements A, B is given such that the same crystal structure for the dilute solution of B in A, which one of the following is true? First of all, according to the Hume-Rothery rule, if two components mix together, they have same crystal structure, then the energy of the mixing will decrease. And we also know activity is equal to gamma into Xa. If AB is equal to gamma B XB, AB is less than XB if gamma B is less than 1. Okay. So the answer is, okay, the dilute solution B in A. So the delta H of mixing will be less than 0 as we are forming the energy of the system decreases, and then the AB is less than 1. For the zeroth order reaction, which one of the following is false? The concentration versus time plot is a straight line. This is true because R is equal to minus dc by dt is equal to k into c naught plus 0. So dc is equal to minus kt. So c is equal to minus kt. Sorry, minus kt. So the concentration versus time plot will be a straight line. The increase in concentration of reaction increases the rate of a reaction. No, it does not depends on the rate of a reaction. So increase in concentration does not have any effect on rate. The half-life depends on initial concentration and the zeroth order rate constant. This is also true. The half-life, if you'll consider C minus C naught, dc is equal to k dt. So it depends on zeroth order rate constant. The rate of a reaction depends on temperature, right? Because here it depends on K. So dc by dt is directly proportional to K, and the K is dependent on temperature. So except the everything else is true. The melting point of copper at 1358, the enthalpy of melting is given as 13 1 lakh 13,400, and the value of free energy change for the liquid to solid transformation at 1058 Kelvin is. Here we know for solid to liquid transformation, delta G is equal to delta H into delta T by Tm. So delta H into 1 minus T by Tm. It is 13,400 into 300 by 1358, which is equal to 2960.235. But here, the transformation is given from liquid to solid. So delta G will be negative. So delta G is equal to minus 2960.235 joule per mole. So it is minus 2960. The vacancy concentration in a crystal doubles upon increasing the temperature from 27 degrees to 127 degrees centigrade. The enthalpy of the vacancy of the formation is given by, we know NV is equal to exponential minus QV by RT. So vacancy concentration. So in case 2, when it is 2 NV exponential minus QV by RT2. So it is 1 by 2 exponential minus Q by R, 1 by T1 minus 1 by T2. So it is ln 2 R ln 2 is equal to Q into 1 by 227 plus 273, it is 300. 300 minus 1 by 400. So it is nearly Q is equal to 6.9 kilojoule per mole. The answer is 6.9. The number of degree of freedom for the following reacting system. Uh, M solid plus CO2 is equal to M solid plus CO gas. See, in a reacting system, F is equal to C minus P plus 2. The components are totally in a reacting system. You need to see what are the reactants present here. So the components present are two. Phases present are solids are two different phases, and the gases are is a mixed composite. But here it's completely forming MO solid and MO gas. So it is minus 2 plus 2, which is equal to 2. The condition for getting the binary phase diagram of AB, a liquid solid, the weight percentage of B, 100%, the delta H solid mix, enthalpy of mixing of solid, delta H of liquid mixing, enthalpy of mixing of liquid. So here you have to remember that delta H mixing is nothing but omega of XA, XB, where omega is interaction parameter. Omega is given by Nz into epsilon AB minus half of EAA plus EBB. So, epsilon BB. These are nothing but bond energies, the bond strength. For the given phase diagram, solid phase is stable at higher temperature. This means AA bonds are, so this solid phase is pushing the liquid phase, and then it is trying to exist at higher temperature. This means AA bonds and BB bonds are weaker and AB bonds are stronger. So energy formation of AB is lesser than, so omega is negative. The energy bonds of AB is lesser than this. So omega of solid is negative, and then delta H of solid mix is less than 0. But for liquid, the omega of liquid is nearly equal to 0 because AB is completely miscible to each other. So delta H of liquid mixing is equal to 0. So this is for the equilibrium reaction. Two copper solid plus SO2 gas gives rise to Cu2s plus O2. The value of ln PO2 by PSO2 at 973 Kelvin is dash. 2 Cu plus 0.5 S2 is equal to Cu2s. Delta G naught is at 973 Kelvin is minus 100 kilojoules. SO2 is equal to 0.5 S2 plus oxygen. Delta G naught at 973 Kelvin is 292 kilojoule per mole and R is 8.314. So the delta G values are given as 100, minus 100 and 292. So if you'll combine these both, plus SO2 is equal to Cu2s plus O2. Delta G naught is equal to plus 192 kilojoules. So delta G naught is equal to minus RT ln PO2 by PSO2. As Cu2s and are condensed phases, you consider their activities as 1. So 192 into 10 power 3 by minus 8.314 into temperature 973 is equal to ln PO2 by PSO2. So this is the value which is asked, which is equal to minus 23.73. One mole of an ideal gas at 10 atmosphere and 300 undergoes an adiabatic expansion to pressure of 1 atmosphere. The work done by the gas is. See, these kind of questions are not explained by many of the coaching institutes, so listen to them carefully. You know, Cp minus Cv is equal to R. Cv is equal to 2.5 R minus R, which is 1.5 R. So we know PV per gamma is constant. for an adiabatic process. So in an adiabatic process, work done is given by P2 V2 minus P1 V1 by 1 minus gamma. So these derivations you can find it out easily. R into T2 minus T1 by 1 minus 5 by 3, which is equal to 8.314 into 119.432 minus 300 by 1 minus 5 by 3. So, how to get this temperature? We know V power gamma is constant. So, you can put V as RT by P. So, it is P power 1 minus gamma into T power gamma is constant. Okay. So, you can put the values here. Then you get T is equal to T2 is equal to T1 into P2 per whole power gamma minus 1 by gamma, which is equal to 200 into 1 by 10 whole power 5 by 3 minus 1 by 5 by 3. So if you'll calculate, you'll get 119.43 Kelvin. And work done is 2251.86 joules. The figure shows entropy versus temperature, a plot of a reversible cycle of an engine. If T1 is equal to 200 and T2 is equal to 600, the efficiency of the engine. The efficiency of engine is given by total work done by the input energy. So it is 1 minus Q2 by Q1, input heat. This is nothing but Q1 minus Q2. Or you can write it as 1 minus T1 by T2. Okay. So this is equal to 600 minus 200 by 600, which is equal to 2 by 3, 67%. The efficiency is 67%. Coming to corrosion, GATE 2021 questions. If E naught is the reduction of nickel, reduction potential of nickel is minus 0.25, then the value of mu naught nickel is at 298 Kelvin is. Okay. So the reaction is nickel plus 2 electrons gives rise to nickel. So E naught of nickel plus 2 to nickel is minus 0.25 volts. You know delta G naught is equal to Gibbs free energy delta G naught nickel minus delta G naught nickel plus 2. So for a pure solid this is 0, and for delta G naught Ni plus 2 is equal to minus mu naught Ni plus 2. So you know delta G naught is equal to minus NF E naught. So minus mu naught Ni is equal to minus 2 into minus 0.25 into 96,500. So mu naught Ni plus 2 is equal to minus 96,500 by 2, which is equal to minus 48,250 joule per mole. Okay, minus 1,250 joule per mole. At iron 25 degrees corrodes in a deaerated cell acid of pH 3 with a corrosion current density of 4 microampere per centimeter square. The corrosion potential V is rounded off to two decimals. Beta C is 0.1 per decade of current density. Exchange current density is given as 10 power 9 ampere per centimeter square. R is given, F is given, all the potentials. So the corrosion potential, first you need to see iron in a deaerated cell. So over potential equal to E corrosion minus E at equilibrium. E at equilibrium is minus 0.0591 pH, which is equal to minus 0.0591 into 3, 0.1773. And now NC is equal to beta C log IC by I naught. Okay. Now beta is given as 0.1 log 10 power minus 9 by 10 power minus 6. This is equal to minus into 4. So minus 0.36. And C is equal to E for minus E equilibrium. So minus 0.36 equal to E corrosion we have to calculate minus of minus 0.1773, which is equal to E for minus 0.36 minus 0.1773 is equal to minus 0.5373. The nickel undergoes isothermal oxidation at 800 °Kelvin for a duration of 400 seconds, resulting in a weight gain of 2 milligram per centimeter square. The weight gain after a duration of 1600 seconds is, the weight gain is proportional to square root of time. So here W1 by W2 whole square equal to T1 by T2. Now, the time duration is 400 and 1600. So it is equal to 400 by 1600. Root is equal to W1 by W2. The initial weight gain is 2 milligram. So it is 1 by 4. So final weight gain is 8 milligrams. It is 8 milligrams. To 1 by 4, sorry, 1 by 2. This is equal to 1 by 2. So it is 4 milligrams. Okay, thank you.